Greetings. Today we're going to be talking about the formula for theoretical probability. This formula is given above, and it's the number of ways A occurs divided by the total number of outcomes. So let's talk about how to use this formula. And as an example, we're going to consider tossing a coin 3 times. I have two questions here. What's the probability the coin lands heads twice? What's the probability the first coin lands heads? So in each instance, we're asked for probability. We need to use the formula above to calculate the probability, and we need to know what is A in this instance, and what is the total number of outcomes. So the total number of outcomes, that's given by the size of the sample space. So let's first figure out the sample space. The sample space is typically just denoted by an uppercase S and is the total number of possible outcomes. So here it can be that the first coin lands heads, the second toss lands heads, the third toss lands heads. Then the next thing we're going to do is we're going to start enumerating all of them. So now I'm going to have the last one land tails, and we're going to keep enumerating. And now we're going to get to 2 tails, so it'll look like this. And finally, the last outcome is given by all tails. Now this is the sample space. The total number of outcomes for this experiment, well, we need to consider it. Total number of outcomes, well, let's just count. 1, 2, 3, 4, 5, 6, 7, 8. So you should have counted 8. And we could count and enumerate all the possible outcomes, or we could use the general counting principle. We're tossing the coin 3 times, and we multiply the possible outcomes. So the first toss of the coin has 2 outcomes, heads or tails. The second toss of the coin also has 2 outcomes, heads or tails. And the third toss of the coin also has 2 outcomes. So we get 8 by enumerating all possible outcomes or by using the general counting principle. And this just says if an event A occurs in n sub A ways and B occurs in n sub B ways, well, they occur together by multiplying them. And if you have more than 2 events, you just repeat this process and keep multiplying the events together. So that's the general counting principle. That's one way in which we formed our total number of outcomes. And here we're going to define the set A. So here A is the event or set of outcomes that corresponds to this. And what this is the event the coin lands heads twice. And, by event, synonymously, we also mean set. Let's just go back to our sample space. In how many of these outcomes does it land heads twice? Well, I count heads, heads, tails, and I'm going to abbreviate so I don't have to write every single piece of notation down. So that will be the heads, heads, tails outcome. Then this will be heads, tails, heads, and the difference here being the order in which it occurs. Here the last, so heads, heads, tails is that the last toss lands tails. Heads, tails, heads, that the second toss lands tails. Okay? And finally, tails, heads, heads. These are the three outcomes associated with the event. And so this is our set. You should note, A is a subset of S, the sample space. The sample space being the set of all possible outcomes. So of course, A needs to be a subset of it. It's a subset because every member of A is also a member of S. Okay. Well, now we can answer that first question. And the probability of A, well, it has three outcomes. So the numerator is 3, the denominator is 8. It's 3/8. Okay. While I'm talking about sets, I can also just mention something called the complement. And this has many notations. It has A bar, AC, and some books also use A prime. And what this is, it's the set of events not in A, but in S. So if I had to list this, well, I go back up to my sample space, I look at what's in A, then I look at what's in S, and I just take those events out of S. So if I do that, heads, 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 tails, 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 heads, tails, and then finally all tails. Now, we should notice that A and A complement, they share no events in common. So A intersect A complement, this is the empty set. No members in common. Okay. Now finally, A union A complement, this is the set of all events in A or A complement. So it shouldn't be a surprise that this is the entire sample space itself. That's almost by definition. Okay. Now, there was a second question here. Question 2 is, what is the probability the first coin lands heads? Intuitively, we know the answer to this, but let's write it out. So I'm going to let B be the set of events so that the first coin lands heads. And if we just start writing this out, the first coin is heads, so heads occurs there. Heads, heads, heads is one of them. First coin is heads there. And that's the criteria, right? The first coin is heads. So we're just going to insist that the first toss be heads. Okay? And that's all possible outcomes where the first coin is heads. So if I write out P of B, this is going to be 4 out of 8. That's 50%. Half the outcomes. Okay. So intuitively we knew this was 50% because it's toss of a fair coin, and it's only concerning the first toss. Okay. Now I just want to reiterate some things. So I've defined this set to be B here, and just to reiterate some concepts, the intersection of A and B, that's the set of elements they share in common. Well, what do they share in common? I think that they share this event in common, right? And then we have to go back up to the set of A and find that there. Heads, heads, tails. Now, we also see they share this event in common, heads, tails, heads. So if I was to write out the intersection as an exercise, it would just be to write down those two events. Heads, heads, tails, and heads, tails, heads. So they share two events in common. And if I was asked to calculate probability of A intersect B, that's going to be 2 out of 8, or 1/4. Okay. Okay, so great. That's the intersection. Let's do one more. And that will be the union. A union B, that's the set of stuff that's in A or B. So we just start by writing out what's in A. Heads, heads, tails. Heads, tails, heads. Tails, heads, heads. And it just needs to be in one of these two sets. You should notice, hey, we just wrote down, so we just wrote down everything that's in A, so now we start writing down what's in B. Okay, and B is this set of heads, heads, heads. And then we go to our next one of heads, tails, tails. Then we go to our next one of excuse me, just a second there. I wrote one out of order. It should have been heads, 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 then heads, tails, heads, heads, tails. But we'll notice, hey, this heads, heads, tails, that's already counted right here. So we don't rewrite that event. It's one event, okay? So it's already listed. We don't need to list that event. Now the next event is heads, tails, heads, tails, heads. That's already listed.